Good morning, students. In today's class, we are going to learn about data representation. Yeah, these are the different number system we discussed in the last class. Yes, decimal, binary, octal, and hexadecimal. And in today's class, we are going to discuss how to convert between these bases. Okay, decimal with base 10, how to convert from base 10 to base 2 or from base 2 to base 10 and base 2 to base 8. Okay, how to convert among the bases. The conversion between all these types are possible. Okay, you can see this. Decimal can be converted to binary and binary can be converted back to decimal. Okay, why we need this conversion? Why do we convert among the bases? What is the need for this? Because computer stores the number in the form of binary, okay, in the form of zeros and ones. And we can't give the numbers in the form of zeros and one. We can't understand that numbers. We use, human use normally the decimal numbers. So when we enter the decimal numbers using high-level language programs, high-level language programming, when we write program, we use decimal numbers. We enter decimal numbers to the computer. And internally, it has to be converted to binary for storage and processing. And octal and hexadecimal in the same way. Okay, so we need to convert. We need some method for converting between these numbers. So we are going to discuss how the conversion between these numbers can be done. So converting among the bases, first is converting to decimal, converting from any other form to decimal. Okay, the procedure to convert from any form like binary, octal or hexadecimal back to decimal, okay, in the user understandable form is, the procedure is to multiply each digit by an integer power of r. Okay, r is the radix if the number is binary. Okay, if we want to convert a binary number to a decimal number, the base or radix is 2. Okay, so r power the integer number. The integer number refers here is the position. If the digit is at 0th position, we write r power 0. Okay, the multiply each digit by an integer power of r. Okay, so if suppose the digit is 1 into r power 0 if it is in 0th position, and if it is in first position, we write 1 into r power 1, and second position r power 2. Okay, we multiply, and then the second step is sum of all the weighted digits. Okay, we multiply and add up all these digits, so we get the decimal number. The result we get is the decimal number. Let me explain this with an example. The procedure is again multiply each digit. Okay, if it is the binary number, when we convert to decimal, the number the number to be converted may be a binary number or an octal number or a hexadecimal number. So we take digit by digit, every digit, and multiply that by an integer power of r. Okay, so r power the position. Okay, r power 0, r power 1 and r power 2 and so on, and find the sum of all weighted digits. So here is an example. This is just decimal to decimal. We don't need to convert a decimal back to decimal, just to understand, explain the procedure. Okay, to understand the procedure, I have given this here. If the number is 724 with a base 10, okay, because it's decimal, we give the base 10 here. How we convert? There are 3 digits, and the first digit is at 0th position, second digit is at first position, position number 1, and third digit is at second position. So this is second position. So we take the 7, the digit, and multiply that by, as it is of base 10, we multiply that with 10 power 2. And the second digit, take the second digit, 2 into 10 power 1 because it is in first position, and the third digit, 4 into 10 power 0. Okay, multiply this, 7 into 100, that is 700, 2 into, yes, 2 into 10 power 1, 2 into 10 is 20, and 4 into 10 power 0 is 1. So 4 into 1 is 4. Okay, when we add up, we get the same number. This is how a number, decimal is. This is to understand the procedure. Take the first number, okay, multiply it with a number that is the base. Okay, base of the number is 10 here. So 10 power 2. What is 2 here is the position. Okay, it is at second position. 0, 1, 2, second position. So it is 7 into 10 power 2. And the next digit 2, take 2, digit 2, 2 into 10 power 1 and 4 into 10 power 0, multiply and add up those numbers, you get the decimal number back. And if there is a decimal point here, 724.5, okay, the same way, 7 into 10 power 2, 2 into 10 power 1, plus 4 into 10 power 0, plus this 0.5. It comes after the decimal digit, so we multiply this with minus 1. Here the power goes like 10 power minus 1, minus 2, the next digit. Second digit after decimal point will be multiplied with 10 power minus 2. And the third digit 10 power minus 3. Okay, so here as this is the first digit after the decimal point, 5 into 10 power minus 1. That becomes 0.5. Okay, when we add this up to this number, we get 724.5. Okay. And how to convert a binary number to decimal? The same procedure. It is all any other number. The number in any other form to decimal. Okay, we follow the same procedure. Now here the number given is 101011. And to the position, if you see, this is at 0th position, first position, second, third, 4, 5. So this number has to be multiplied with 2 power. As it is binary number, it has the base 2. So we multiply with 2 power 5. Okay, first number 1 into 2 power 5. And the second number is 0. So 0 into 2 power 4 plus. Third number is 1. Third digit is 1 here. So 1 into 2 power 3 plus 0 into the fourth digit is 0. 0 into 2 power 2 plus 1 into 2 power 1 plus 1 into 2 power 0. Okay, so when you multiply this, 2 power 5 is 32, 1 into 32 is 32, and next is 0. Then again 1 into 2 power 3, 2 power 3 is 8. Okay, then 0 here, the next digit is 0. Then 1 into 2 power 1, that is 2, 2 plus 1 into 2 power 0, it is 1. Okay, so when you add up, you get 43. So here I have given another example. Yes, how we convert this to binary? The position here are 0, 1, 2, 3, 4, 5. Okay, so this, I already told you this first digit, the rightmost digit is called the least significant digit, and the leftmost digit is called the most significant bit. Okay, 0 here at the least significant bit position we have 0, and at the most significant bit position we have 1. Okay, now let's start from the most significant bit position. Before that, let's check the position. It's 0th position at the least significant bit, and 1, 2, 3, 4, 5. So first write 1 into, as it is binary number, base 2 power 5 plus 1 into 2 power 4 plus 0 into 2 power 3 plus 1 into 2 power 2 plus again 1. So 1 into 2 power 1 plus 0 into 2 power 0. Okay, so this becomes 2 power 5 is 32. So 32 plus 2 power 4 is 16 plus 0 into 2 power 3 is 0 plus 1 into 2 power 2, that is 4, plus 1 into 2 power 1 is 2, plus 0 into 2 power 0, that is 0 into 1 is 0. Okay, so we get, what is the result we get here? 32, it's 54, right? 54 to the base 10. It is the decimal. 54 is the decimal equivalent of the binary number 110110. Okay, so the binary equivalent of, sorry, the decimal equivalent of 110110 is 54. Okay, this is how you convert a binary number to decimal. And let's take an octal number. Okay, let's take an octal number and convert it to decimal. We follow the same procedure. To convert from any form to decimal, the procedure is the same. So here is an example, 724. Okay, it's an octal number, so it takes it has a base 8, 724. And the position, if we check the position, at the least significant bit position we have 4, and the next position is 2, next digit is 2, and the next most significant bit is 7. 0, 0, 1, 2. Okay, so we have, yeah, the most significant bit is at second position. So 7 into 8 power 2 plus 2 into 8 power 1. Second digit is 2. 2 into 8 power 1 plus the least significant bit 4 into 8 power 0. That gives 448 plus 2 8s are 16 plus 4. 4 into 8 power 0 is 1. So 4. And that is, when you sum up all these, you get 468, okay, which is a decimal number. So we say that the decimal equivalent of the octal number 724 is 468. Okay, 468 is the decimal equivalent of octal 724. And let's do, let's convert the 736.4 to the base 8 to decimal. How we convert? Here we have a decimal digit. So here is the 0th position. 6 is at the 0th position, least significant bit, and 3 at digit 3 at first position and 7 at second position. So we write 7 into 8, as it is octal number, we give the base 8, 8 power 2 plus 3 into 8 power 1 plus 6 into 8 power 0. That is equal to 8, so 64 into 7. It is 448. Okay, plus 8 3s are 24 plus 6 into 1. It is 6. Sorry, here we left this, we missed this decimal digit. Decimal digit is 4. So we write 4 into 8 power minus 1. As it comes after the decimal point, we start after the decimal point, we start from minus 1, minus 2, and minus 3 like that. So here we have 4 into 8 power minus 1. So it is 4 into 1 by 8, right? So 1 by 2, which is 0.5. Okay, so when you add up these all, you get 478.5. Okay, this is the decimal equivalent of octal 736.4. And next, let's see how to convert a hexadecimal number to a decimal to decimal. The procedure is the same. So let's take hexadecimal numbers. We know the digits, it includes the digits from 0 to 9 and alphabets from A to F, right? Where A is equivalent to 10 in decimal, B is equivalent to 11, and so on. So here, if this is the hexadecimal number given, to convert it to decimal form, we take there are 3 bits Okay, first bit is C, that is at 0th position, and B at first position, and A at second position. So we write the most significant bit, we take A into 16 power 2. 16 we give because it is the hexadecimal number. Okay, 16, which has the base 16, 16 power 2, plus the second digit B into 16 power 1, plus C into 16 power 0. Okay, when you multiply this A, we can't, it's an alphabet, we can multiply, so we take the equivalent, decimal equivalent, that is 10. Okay, the decimal equivalent of A is 10, so we write 10 into 16 into 16 is 256, plus B is equivalent to 11. Okay, in place of B we write 11 into 16 power 1, plus C is equivalent to 12. Okay, so 12 into 16 power 0 is 1. So when you add up all these, you get 2748. This is the decimal equivalent of hexadecimal ABC. Okay, let's try to do one conversion here. Let's take this B28, a hexadecimal number B28. How we convert this? There are 3 bits. Least significant bit is 8, and the bit at middle position is 2, and at the most significant position we have B, 0, 1, 2. So B into 16 power 2 plus 2 into 16 power 1 plus 8 into 16 power 0, which is equal to, B is equivalent to the decimal 11. Okay, A is equivalent to 10 and B is equivalent to 11. So 11 into 16 power 2 plus 2 into 16 plus 8 into 1. That is equal to 11 into 16 power 2 is 256, right? 216 or 32 plus 8, and 256 into 11 is 2844 plus 32 plus, sorry, I added up all this. It's 2800 and
To 816, ma'am.
yes, 2816 plus 32 plus 8, which is 1856, right?
298, ma'am.
Yes.
2928.
No. 2816 is 256 into 11 is 2816 plus
2816.
2 plus 8, 40. So it is 2856. Okay, so the decimal equivalent of hexadecimal B28, okay, is 2556. And the next conversion is converting from decimal to other representations. Okay, if a decimal number is given, how to, yes, there is some disturbance coming from the, all of you mute yourself. You can write it down. I'll give you some numbers to convert. You can work it out from home and try these conversions. All of you have notebooks with you?
Yes, ma'am.
Yes. Write these numbers. Now I give some binary numbers. You have to convert to decimal. Okay. It is yes, the number is 110110100. Okay, a binary number 110110100. We will discuss the we'll discuss the answer in the next class, the decimal equivalent. And the yes, the next number is 101110. Okay, a binary number 101110. You need to convert these two binary numbers to decimal. And this is the first part. And the second question is, yes, convert 4 to 6. Okay, octal number 4 to 6 to decimal. And the other number 723 to the base 8 to decimal. Okay, this is from octal. And the third one is convert F3, a hexadecimal number, base 16 to decimal. And the other number FA7C2 to decimal. Okay, convert these two hexadecimal numbers to decimal. Okay, you can do these. You can convert these numbers given, binary, octal and hexadecimal, to decimal, and you can tell me the answers tomorrow, or we will check it tomorrow. The video what is being recorded in the class is uploaded in the YouTube college channel. Have you seen that?
No, ma'am.
Why? It is uploaded as CO. Should I? Okay, I will share it in the WhatsApp group also if you want. You can check it, right? In the college channel. The previous class video, okay, there are two videos already uploaded, and today's video also will be uploaded. You please check it, okay? And the notes for the introduction, basic structure of computers, I will share by today, okay? Every part as and when it is completed, I'll try to send you so that you can also keep learning. And you also refer the book, okay? What I said yesterday's in the yesterday's class, the page numbers I gave you. And we have the chapter called data representation in the book, okay? All these number system is totally given in that book, okay? You can refer that particular chapter, read that chapter, data representation, for today's class, and I'll send the notes to you later for today's class. Okay, and yesterday's and day before classes notes I will send by today. Any doubts?
No, ma'am.